Alright, I'm going to do two problems from the group quiz that people seem to have the most trouble with. So we're going to do numbers 3 and 4 from the group quiz. We'll start with number 3. So number 3, we're finding the force on Q1. So we got three charges. We got 1, 2, and 3. Charge 1 is negative 14 microcoulombs. Charge 2 is negative 6.4 microcoulombs. And make that negative a little better there. And charge 3 is 8.9 microcoulombs. Distance between 1 and 2 is 0.41. Distance between 2 and 3 is 0.54. Let's find the directions. We're looking for the forces on 1. So force 2, or the charge 2 is going to apply a force on charge 1, and they're both negative, so they're going to repel. So you got to think about if charge 1 was moving, and charge 2 and 3 are stationary here. So if charge 1 was moving, charge 2 would be pushing it to the left. So we're going to say force 2 on 1 is pushing it to the left. And for 3, we have force 3 on 1. They're attractive, so if 1 was moving and 3 was stationary, 1 would be moving to the right. So it's going to be force 3 on 1 moving to the right there. I'll shrink this part down a little bit. Alright, so we're going to find these two and end up subtracting them. So first we'll find force 2 on 1. It's going to equal kq1 q2 over the distance squared. So k is 9 times 10 to the 9th. Q2 in this case, negative 6.4 times 10. What happened to that 10? Times 10. Just one more time. Times 10 to negative 6th. Times negative 14 times 10 to the negative 6th. All over the distance between 1 and 2, which is 0.41 quantity squared. We do that, we should get force 1 on 2 equals 4.8 newtons, as our negative signs cancel out, and we drew from our arrow that that's pointing to the left. Now we're going to do force 3 on 1. It's going to equal 9 times 10 to the 9th for k, times Q3 is 8.9 microcoulombs. We got to convert that to coulombs, so 8.9 times 10 to negative 6 coulombs, times negative 6.4 times 10 to negative 6 coulombs. All over the distance between them squared, so it's going to be 0.41 plus 0.54 quantity squared. Make that 0.54 a little better. And we do that math, we get force of 3 on 1 is equal to 1.24 newtons. And that we end up with negative, but we're going to drop that negative and just put it in the direction we drew up here. So it's going to be 1.24 newtons to the right. And since we know our total is moving to the left, all I'm going to do when I add them up is I'm going to make left positive and right negative. I'm just going to say the force total on charge 1 is going to be equal to 4.8 newtons minus 1.24 newtons, and that ends up equaling 3.56 newtons left. Alright, so that was number 3. Move on to do number 4 now. This is probably the trickiest one in the group quiz. So for number 4, we have 4 charges this time. So we've got 1, 2, 3, and 4. We have 1 is negative 35 microcoulombs. 2 is 45 microcoulombs. 3 is negative 45 microcoulombs. And 4 we don't know. We also know this distance between 1 and 2 is 0.48. meters. The distance between 2 and 3 is 0.46 meters. Distance between 3 and 4 is 0.35 meters. And we also know the total force, and we're looking for, we know the total force on 3 is equal to 46.55 newtons to the left. So this is the one we're trying to find everything on, because that's what we're given the total force on. Alright, so we're going to ultimately be trying to figure out, the equation we're going to be working with is the total force on 3, since, actually, can I... Alright, never mind. I'd like to draw in the arrows here that I kind of forgot to do, so I'm going to erase this real quick. Maybe? Maybe not. Okay. This isn't going well. We'll draw the arrows in here. Alright, so 1 on 3, let me redraw it down here and we'll just go 1, 2, 3, 4. So we've got force 2 on 3, since this is positive and negative. Not 3, it's negative. We're going to have force 2 on 3. So on 3, 3 is the one that's moving again here. So force 2 on 3 is going to be pulling 3 to the left, so it's F2 on 3. F1 on 3, since 1 is negative, it's going to be pushing F3 to the right, so that's F1 on 3. And F4 on 3, we don't know anything about that direction yet, so we'll talk about that one in a second. Alright, so that did not go well. I'll try to do better for the rest of the problem though. Alright, so now we're going to find our overall equation for this is going to be the total force on 3 equals anything moving to the left, so that's F2 on 3, minus anything moving to the right, F1 on 3, and we're just going to say plus F4 on 3, and then we'll figure that part out later, whether that's going to be plus or minus 4 on 3. Alright, I'm going to take that. Oops. Move it up there. I don't know why I can't shrink that down. Alright, so our next one, so now we're going to find F2 on 3 and F1 on 3. So F1 on 3 is going to be equal to 9 times 10 to the 9th times negative 35 times 10 to the negative 6th multiplied by 45 times 10 to the negative 6th. That whole thing over 0.48 plus 0.46 quantity squared. When we do that math, we should get that one equals negative 16.04 newtons, and that we're going to drop that negative and just make that 16.04 newtons right. Hopefully I'll be able to shrink this down. There we go. And now we're going to do force of 2 on 3, and that one's going to equal KQ1, Q2 are the distance squared again, 9 times 10 to the 9th times 45 times 10 to the negative 6 coulombs for charge 2 times negative 45 times 10 to the negative 6th. It should be a negative right here, guys. I'm sorry. So that should be positive. And it's still to the right, though. 10 to the negative 6 coulombs all that over distance between 2 and 3 is 0.46 meters, quantity squared. If we do that math, we get F, force of 2 on 3, is equal to negative 86.13 newtons. So now we're going to drop the negative, and we'll get our arrow, and that one's pointed, F2 on 3 is pointed to the left. So now we get 86.13 newtons left. Let me shrink that down. Oh, and we're shrinking that down up there too, so that's really tiny. So now our last step here, we're going to use our total force equation, the Ft3 equals F23 plus F minus F13 plus F43. So our total force is going to be 46.55 newtons, and we're going to make left positive and right negative, so equals F23, so 86.13 newtons minus the right force, which is 16.04 newtons, and that's we're going to say plus the force of 4 on 3. When we solve that, the force of 4 on 3 ends up being negative, so we end up with negative 23.54 newtons, and we get, and so that, since that's right is negative, we're going to say 23.54 newtons right is what F that has to be. We're going to take a quick break, and my daughter Leah is going to say hi. Can you say hi, Leah?
Hi.
You want to say anything else to any of the kids?
Yes.
What do you want to say?
Are you asleep? What time do you go to bed?
Alright, that's probably enough. We'll get back to the physics here shortly. Alright, so back to physics now. We're just going to kind of move that up a little bit. So now we know that since the force of 4 on 3 has to be pointed to the right, that means that 4 has to have a positive charge to bring 3 to the right. So now that would be pointing that way. So we'll find our answer, and then we'll just make everything positive in it, and we'll know that our charge of 4 has to be positive. So we're going to say 23.54 equals KQ1, Q2 over the distance squared again. So 9 times 10 to the 9th times is negative 45 for 3, but we're just going to make it positive to ensure we get the right answer. 45 times 10 to the negative 6th times Q4, all over the distance between them, which is 0.35 quantity squared. And we do that math. I'm losing everything here up there, but that's okay. We do that math, we get Q4 equals 7.12 times 10 to the negative 6 coulombs, or 7.12 microcoulombs. Again, sorry that was kind of a mess there, guys. If you have questions about it, I can explain it during class.